Today we're going to be looking at section 2.10, Cartesian coordinate system. This is another one of those day one, day two things where we're going to spend a couple of days on material that really is all the same material. It's just kind of split between 2 days. The first thing what we're going to look at specifically today that separates it from next week is that we're going to be specifically graphing lines. We're going to be graphing more generally next week, but graphing lines today. Every 2 points lie on exactly one line. And because that's true, we really only need to plot 2 points to be able to graph a line. That's very unique. Every other graph, 2 won't cut it. It will not give you a picture of what's going on, but for lines, it's enough. So we're going to be plotting a whole bunch of lines. That's our next thing that we're going to take a look at. And we're going to start with some lines that are very familiar looking. Y equals negative 2x, y equals negative 3x plus 2. We're doing this in this lesson from the perspective of plotting 2 points. You can be any 2 points you'd like. But what we're going to do is we're just going to create an xy ordered pair, and we're going to choose 2 x values and decide what y values correspond to them. For example, it's often nice to choose an x value of 0. You don't have to, but it's nice most of the time. So if I put 0 in for x right here, negative 2 times 0, what will I get? 0. So this one happens to cross at the origin. And again, another value that's often nice to plot, but again, you don't have to use this point, is the value 1. So if I plug in 1 for x, negative 2 times 1 is negative 2. So I'm going to plot these 2 points on my coordinate plane. I know you don't have a coordinate plane. It's fine. You're welcome to get grid paper from online if it would make you feel more comfortable to graph on an XY, like a ordered axis. It's perfectly fine for you to simply draw in what's necessary as well. We would plot the point 0, 0. I'm going to plot the point 1, negative 2, which mine's down here on my graph. My grid mark's nicely marked. And then I should be connecting them with a straight line. If you want to grab out maybe your ID card or license, something like that, or maybe the edge of a notebook, it will help you to keep your lines straight. We're going to connect them, and we're going to draw arrows on the end to indicate that they continue on in both directions forever. So this would be our first line. Okay, let's say you didn't pick the points x equals 0 and x equals 1. That's fine. Maybe you picked x equals 4 and x equals negative 6. Go for it. I'm just looking for 2 points that are plotted correctly and then them connected correctly, wherever you'd like them to be as you choose them. The next one, we're going to do the same thing. We're going to choose an x value and a y value. So just to show you that it doesn't really matter, we're going to pick something different this time. So let's say that we pick x equals negative 2. So if I do negative 3 times negative 2 plus 2, what's negative 3 times negative 2? 6, and 6 plus 2 is 8. So that's one of my points. Okay. And maybe I decide I want to pick positive 2 on the other side. So instead I've got a positive 2 here. So negative 3 times positive 2 is negative 6. And negative 6 plus 2 is negative 4. So maybe you pick these 2 points. If you want to put x equals 0 and x equals 1, more power to you. You get to pick. So negative 2, 8 is one of my ordered pairs. So that's right here. And 2, negative 4 is my other one, and that's right there. Okay, so your 2 points do not have to be the same as mine, but your line will be the same because okay, this is not perfect. I'm going to fix it, trust me. In order for the 2 points to lie on the same line, they actually have to be the same for any the line has to be the same for any 2 points we pick. So my 2 points might be different from Brady's 2 points, might be different from Gracie's 2 points, might be different from Nadia's 2 points. It doesn't matter. We'll get the same line. Arrows on the end to indicate that the direction continues. So far, so good? Okay, number 3 is a really good example why you might not want to always pick x equals 0 and x equals 1. So 0 is fine. So I'm going to pick x equals 0 again this time. It's cool. What happens if I plug 0 in for x here? What do I get? 1, right? Yeah. But choosing x equal 1 means I'm going to have to deal with fractions. And plotting fractions on my grid is probably not going to be super clean and tidy, right? It's just probably not. So a better value to pick for x might be the value 3. Can anybody tell me why I think 3 might be nice? Because there's a 3 in the denominator of that fraction specifically, right? Yeah, that's exactly why. So the 3 in the denominator of the fraction means that if I choose 3, the 3's will cancel, and that's friendly. So 3 is a nice choice. But honestly, anything that cancels with that 3 would be an equally nice choice. Maybe you choose -3. Maybe you choose 6. Maybe you choose 9. Any of those values that cancel with that 3 are going to be a nicer choice for this one than just randomly choosing or choosing the value 1 like I mentioned earlier on. So the value 3 here is what I've chosen. So the 3's cancel. So I'm left with the 4 plus my 1, which gives me 5. Thank you. So I've got 0, 1, and 3, 5. So 0, 1 would be here. 3, 5 would be here. And then we will connect the dots with arrows on the end. How is number 4 different? It's not written in y equals. If you want to write it in y equals to change it to start with, you could do that. It wouldn't hurt anything. But you don't necessarily have to. It can be written just like this, and we can do the same sort of thing. Not only that, but because it's not written as y equals, it might be friendlier to choose the y value and figure out the x value. For example, choosing y equals 0 here is kind of nice. Because if y equals 0, then this piece goes away, and you can find out very quickly that x is equal to 2, right? So we could actually choose the y's instead of the x's here, which might be kind of nice because the y has a coefficient of 4. It becomes kind of messy if I'm solving for it. So if I wanted to do that, I could. If you want to still choose x values, that's fine too. Doesn't hurt anything. You just might end up with fractions accidentally that you weren't anticipating along the way because it's not already solved for y. I think I'm going to pick another y value and just pick another y value to be the value of 1 and see what happens. So I have x plus 4 times 1 equals 2. What's 4 times 1? 4. So now I have x plus 4 equals 2. What would x have to equal to make this true? We could subtract the 4 from both sides, and if we did, what would we get? A -2, yeah. So Darian's thinking about it like this, which you can totally do. Sorry, I'm now writing on top of my grid, but 2 minus 4 would be -2. So over here, I would have a -2 associated with a y equal 1. Let me shift this up just so you can see it a little bit better. Okay, again, there's nothing special about those 2 points. If you choose something different, that's totally fine. So you're going to have 2, 0, that's here, and -2, 1, that's here. And we're going to connect the dots with a line. That's not very good. Maybe a little bit better. Something like that. Okay, is that all right? But again, if you wanted to solve it for y and make it look like the other problems that we did, you could do that. If you decided to do that, you would subtract your x from both sides. So you'd have 4y equals -x plus 2. And then you'd end up with fractions, right? So you'd have y equals -1/4 y if we divide by 4th plus 2 over 4 or 1 over 2. So you'd have to deal with fractions if you decided to do it from that perspective. Possible, if you'd like that. How are 5 and 6 different than the previous ones that we have done? There's only one variable. And what happens when we have only one variable is that we end up with either horizontal or vertical lines. That's really what happens. The reality is that what this means is that the x value is always 2. So no matter what y value I pick, maybe I pick y equals -5, or maybe I pick y equals 7, or maybe I pick y equals 0. No matter what I pick, x is always 2. So I can plot the point 2, -5, and it would be right here. I can plot the point 2, 7, and it would be right here. I can plot the point 2, 0. I can plot the point 2, anything, because the anything can change, but the 2 can't. X is always 2. So what happens is I always get a vertical line when I'm dealing with an x equals equation. So an x equals equation gives me a vertical line. Okay? All right, the other one must be horizontal because I told you one was one and one was the other. The exact same reason, I can pick any x value I want, and no matter what x value I pick, y is 2. So if x is 7, or if x is -10, or if x is 0, or x is 1, no matter what x value I pick, I get a y value of 2. So these are the two I picked. X equals 7, y equals 2, which would be here. X equals -10, y equals 2 would be here. And we would connect the dots. That's not good. Let me shift it up. Try that again. It's a little bit better. And we would draw our line through them with the arrows on the end. So again, anytime I have y equals a number, these will always yield horizontal lines. Okay. All right, a couple other things that are worth noting here. We've encountered them already once. Our intercepts, x-intercepts and y-intercepts, we've encountered them on the drafts that we've done. An x-intercept is simply the location where an equation crosses the x-axis. And it should say y equals 0. There's a typo in your book. Right now your book says y equals a number. Please mark through. Did you say that? I'm not lying, right? It says y equals a number? Yeah. Scratch that out. That is a typo. It should say y equals 0. And the other one says x equals a number, and it should say x equals 0. Those are typos. So an x-intercept is where you cross the x-axis, and if that happens, y is equal to 0. The y-intercept is where you cross the y-axis, and when that happens, x is equal to 0. So the first question that we have on this is given in the form of actually a graph. And then the second one in the form of an equation. So on the first one, the graph looks like this. And it's asking for the x and the y-intercept. Oh, let me make one note here, and you should as well. These are ordered pairs. And I'll show you what I mean when we get to the next one where I actually give an example, okay? But make your note to yourself, these are ordered pairs. Okay, so over here, can you tell me where am I crossing the y-axis? At what value? What does it look like? My graph is different than yours. Thank you. That's what happens when you copy-paste things sometimes is they don't actually copy-paste the way they should. So ignore my graph. Let me redraw with it the way yours is so that we're on the same picture. This is the graph that we will use. And we're going to ignore this one. Thank you so much for drawing that to my attention. I had not seen that. I've got your same book, but I didn't notice. Thank you. Okay. So Elijah, was that you? Or Cole? Elijah? Okay, so Elijah, you were telling me it's crossing at -2. Okay, so the x value where it crosses is 0, but the y value it crosses at is -2. Does that sound right? Yeah. So when we report the solution or the x-intercept or the y-intercept, we're always going to list an xy ordered pair. The x value here is 0, right? Because I'm right here. I haven't gone left or right any, so the x value is 0, but the y value is -2. So this is the ordered pair 0, -2. If you think about it in that perspective, what could we say that the x-intercept is then? What's the x value? 2. And what's the y value? 0. Okay, so we're always going to list them as an ordered pair. And the reason that we are is because if I just say -2 or I just say 2, those are numbers, they're not points. And I'm supposed to be giving the answer as a point. If you're thinking, okay, well, but I could say like y equals -2 or x equals 2. Those are lines, just like we saw over here, right? So we want to make sure that we're giving the answer in the appropriate notation because they mean something different if you write something else down. These are points. All right, now let's do the same thing for an equation instead of for a graph. Our equation is 3x minus 2y equals 12. So my y-intercept, I'll do it first just because I did on the last one. The y-intercept is when x equals 0. So we take our equation and we evaluate when x equals 0 and we solve. So 3 times 0, of course, is 0. So it leaves me with -2y equals 12. What would I need to do to solve for y? Divide by -2, right? And so what would I get? -6? Yeah. So y equals -6. But the solution, the answer to the question is 0, -6, because it's an ordered pair. Is that all right? That's my y-intercept. You can do these in either order. I just picked one. My x-intercept then is when y is equal to 0. So I have 3 times x minus 2 times 0 equals 12. 2 times 0 is 0, so now I have 3x equals 12. And what would I do? Divide by 3. 12 divided by 3 is 4. So my x-intercept then is an x value of 4 and a y value of 0. Any questions on that? All right, we have one last question. It's a graphing question. Instead of being given an equation like I was in examples 1 through 6 early on, I'm given sort of a verbal description. So my verbal description says that we're going to graph the line whose x-intercept is -3 and whose y-intercept is -2. So I'm going to draw this one with you, and you can make your hash marks. They don't have to be really tight like my grid marks. I didn't say that earlier, but your grid marks can be whatever you want them to be. So if you want them to be really spread out and thick, that's great. They just should look roughly equal, right? So they shouldn't look like really tight on one axis and really thick on one axis or something. So this is what I'm going to mark. It says my x-intercept is -3. So x-intercept is -3 means that it crosses the x-axis at -3. And then my y-intercept is -2 means it crosses the y-axis at -2. So these are the 2 points that I'm described to have. And then I'm supposed to connect them with a line, just like on the other problems. That wasn't a good one. Let's try it again. That's a little bit better. It's actually easier to get it right on there if you're using a ruler than drawing it freehand like I am, sort of. So it looks something like that anyway. Any questions on that? Awesome. Okay, well, this will be our last, not our last, but our homework for this week, homework 21, I think we're at. And then we have one more after this. So we're on homework 22. I'm sorry, we have one more after this, homework 23. So we're really close to being done. If you have any questions, please email me and let me know.